Hello everyone and welcome to this section. In this section, we're going to learn how to try different activation functions and what do we actually mean by different activation functions, okay? So the first activation function we're gonna be covering is what we call it sigmoid activation function. And that's kind of the model of our activation function, okay? First step is the y-axis. So it actually, the function range from 0 to 1, all right? And you will see that, simply put, is kind of the gradient here is kind of, like linear. And then it changes to become a little bit non-linear, and it's kind of there is saturation at the end, okay? So simply put, it takes a number, okay, whatever x value, and it sets it between 0 and 1. That's the whole idea of the sigmoid activation function. Okay, so it converts again, then the next point is converts large negative numbers to 0. So if the number is very large negative, which is very high here, any number, let's say beyond, for example, -5 will be set to 0. Any number beyond 5 will be set to 1, okay? And this is kind of the model of the equation that can be used for the sigmoid activation function. 1 divided by 1 plus e power minus x, all right? Okay, so where can we use a sigmoid activation function? In general, we use sigmoid activation function in the output layer, okay? So in the output, we actually insert this sigmoid activation function to set the output to kind of, let's say to 0 or 1 per se. We can use it for, let's say, binary classification or for a categorical classification, all right? Okay, and that's one of the first, or like one of kind of common sigmoid activation functions, okay? The second activation function we're gonna be using is what we call it the ReLU activation function, which is what we call a rectified linear units function, okay? So this is kind of the function, as you guys can see here. So any number below 0, the input is less than 0, the output is going to be 0. However, if any number beyond or more than 0, we're going to set it kind of in a linear fashion. So the output is going to be x. If x greater than 0, the output will be the same, pretty much x. Okay. One of the key advantages of the ReLU is that it can be used to avoid any, what we call it, the vanishing gradient problem, which means here, for larger inputs from 0, let's say, to infinity, the gradient is still there. The value is still there. We didn't saturate like the sigmoid function, okay? And that's why in our exercise, for example, in the previous exercise, when we set it to ReLU, we use it we use it a lot, like commonly in the hidden layers. And that's where, actually I try to include it here just to give you, so we have an input layer, we have our output layer. Here in our hidden layer, we generally use the ReLU function. It was very effective, very fast, very efficient, because it kind of applies what we call it like thresholding. If it's less than 0, we're gonna set it to 0. If it's more than 0, we'll set it to x, whatever value. Okay, so it's very computationally efficient. I don't need to go and calculate, like exponential values and so on, all right? And again, ReLU function can be used for the hidden layers. Again, please remember, there's sigmoid, there is ReLU, and there is the last one, which is what we call it the hyperbolic tangent activation function. Again, it looks very similar to the sigmoid activation function. The only difference is the range is from -1 to 1. Before, it was from 0 to 1. Here, we're just going to range from -1 to 1, okay? So that's one kind of, that's why we sometimes use the hyperbolic tangent function a little bit more frequent than the sigmoid function. Again, but the only problem with this function is that it again there is kind of saturation here, and that's why you will see what we call it vanishing gradient problem, which in a way kills the gradient when saturated. Once it's saturated, that's it, done, right? And that's why we use the hyperbolic tangent function over the sigmoid. We have kind of a range from -1 to 1 instead of 0 to 1 per se. And again, we can use it in the output layer too, all right? This is just a quick overview of different activation functions. Again, there's a lot of information, a lot of content that I've been giving you guys for the first couple of lectures. The main advantage is once we have all that information, okay, we will be ready to build our single neuron perceptron model in Python, okay? All right, and that's pretty much all what I have for this. I hope you guys enjoyed it, and see you in the next section.